Here we're going to graph each of these two functions in the same rectangular coordinate system. One thing that we want to notice in this problem is that these functions are inverses of each other. In fact, that's how logarithms are defined. They're defined to be the inverses of exponential functions. In particular, the function log base 3 of x is the inverse of the exponential function 3 to the x. Now, if we know that going into the problem, it makes things a lot easier. So you see I've completed a table of values for our exponential function. And so to fill in a table of values for our logarithmic function, again, if we know that that's the inverse of the exponential, we would simply interchange the x and y coordinates. So I'd have 1/9, -2, just simply switching the x and y coordinates. Go through and switch all of them, and these will be points on the logarithmic function. Now, if we didn't necessarily know that going in, that these were inverses of each other, and we were just trying to graph this logarithmic function from scratch, I would start by writing it with a y instead of a g of x. And then I would rewrite this expression, or this equation, in its equivalent exponential form, which would be 3 to the y equals x. Because I'm more familiar with raising things to powers than I am with using logarithms. And so having it in this form is equivalent, but in this case it would be easiest for me to pick numbers to plug in for y, such as -2, -1, 0, 1, 2. So you'd put all those numbers in the y column. Go ahead and plug them in to get their corresponding x values, and you'd fill in the x column in the same way that we have it filled in up here. Okay, so let's go ahead and plot these points. I'll go back to graphing the f of x function first. So we'll plot -2, 1/9. This is going to be our exponential function, -1, 1/3, 0, 1, 1, 3, and 2, 9. And go ahead and connect those with the curve, keeping in mind that that x-axis is a horizontal asymptote. Okay? And another feature of inverse functions is that they are reflections of each other over the line y equals x, which is a line with a slope of 1 going through the origin. But we have some ordered pairs listed for our function g of x, so we'll just go ahead and plot those. 1/9, -2, 1/3, -1, 1, 0, 3, 1, and 9, 2. And again, go ahead and connect those with the curve. Now what you'll notice here as we move toward the left is that we're not going to have a horizontal asymptote this time, but we will have a vertical asymptote at the y-axis. So this graph is never going to touch or cross the y-axis. And that is a result of the exponential function having that horizontal asymptote. And then finally, just so we can see how they are mirror images or reflections of each other over that line y equals x, I'll go ahead and sketch that line in there as a dashed line.